So if you graphed your parent function, y equals x squared here, this is your parent function. I did use graph paper, so put in a 0, you get 0, put in a 1, 1 squared, put in a 2, you get 2 squared, which is 4. And then same thing on this side, because it's symmetrical. Negative 1 goes 1, and negative 2 goes 4. Okay, so there's the parent function there. And when I graph 1/3 x squared, you can plug in points as well. You put in 1, you get 1, but 1 times 1/3 is 1/3. So 1 comma 1/3, that's my order pair. And you put in 2, 2 times 2 squared is 4, 4 times 1/3 is 4/3. 4/3 is a little bit above 1. And do the same thing on this side. And I realize that the graph is not going up as fast as the parent function. So you can say that this a value, when the a value is less than 1, when I mean less than 1, it's between, it's not a negative, but it's just less than 1, so between 0 and 1. It shrinks by the graph by a factor of 1/3. So you can say it gets wider. Raise your hand if you use some kind of language like that. The second one, if you notice that your a value here is 1 and this one is 2, same thing, you can plug in numbers, put in 1, 1 squared, 2 times 1 is 2, so I go 1, 2, and then you plug in 2, 2 squared is 4, 4 times 2 is 8, so I got way up here. And then when you graph your function, yours will look something like that. And you realize that the red function now, the child function, is beating or going faster, going up than the parent function. So what's happening is it's getting narrower or skinnier. Raise your hand if you use some terminology like that.